See, the last topic is about the forwarding and unicasting protocols. So, in the previous class, we have seen different address resolution protocols, how to map the physical address to IP address and IP address to physical address. So, different protocols we have seen regarding that. So, today we will see the different protocols that are related to how to forward the frame and what are the unicasting protocols. So the definition of forwarding and routing. So in this slide we will just read out what is the definition of forwarding the frame, forwarding the packet, and what is the routing and what is the importance of routing protocols. We can see over here routing protocols and what is routing and what is forwarding definition. So what is a forwarding in general? It is nothing but moving it is an action applied by the each router when a packet arrives at one of its interfaces. You see, the network is connected, it is nothing but a connection of a number of host devices to the router, and the router in turn is connected to some internet service provider, right? So whenever there is a need of transformation or transmission of information, so obviously the packet has to move from one point to the other point. It is from one router to the other router, or from one host to the other router, router to host, or host to host. The transmission may takes place like that. We call it as a forwarding. Simply the forwarding, it is nothing but movement of the packet from one place to the other place, or from one router to the other router, one host to the other host. So that is the meaning of forwarding the packet. And to forward the packet, so we need to follow some protocols. So that are called as routing protocols. And these routing protocols, so you need to know what is a routing. Routing means, so you know the router, it is a layer 3 device. The router has some routing table. So it contains some MAC addresses and IP addresses, right? So depending on the MAC addresses and IP addresses, it will forward the packet such a way that the packet will follow the least path. That means, so here the routing table we will use, this routing table may contain the information about different parameters, like what is the cost of the particular path, what is the time delay in that particular path. So sometimes our main agenda will be following the less delay path. So in that case we will choose the path. There will be multiple paths to forward the packet, but we will choose the path that is giving less delay, so that all informations are present in these routing tables. So to do so we are using some set of procedures that are called routing protocols that are continuously used to update the routing tables every time. So we will see that routing table will keep updating. It will come to know, it will, so initially the routing table is a little bit of information, but whenever it is starting its operation, it will keep on updating itself. So with more amount of information, with new amount of information, that is called the routing table updation. So we will update the routing table for the purpose of forwarding the packet in an optimized way. So in an optimized way means, here optimized meaning you can see. So what is optimized? So very important word, optimized. So optimized means we have to forward the packet in its optimized way. Optimized way means in its better way. Like it consumes less delay. The packet will be forwarded with less amount of time. With all that things will come into picture when we talk about optimization. So we'll see what are the differences between the routing, forwarding and switching. Here for routing is nothing but movement of the device data from one device to the another device. Forwarding is also, it is a movement of data from one device to other device, but it contains mainly the data. Whatever the packet we are sending, that contains the data. Okay, so whenever the data is moving from one network to the other network, obviously the data will move from one router to the other router, one device to the other device. That involves switching of the devices. So that is called switching. Here, switching needs the MAC address. The information MAC is required for switching operation. Similarly, for forwarding, the table called forwarding table is required to forward the packet. Similarly, for routing, so you can see the routing. For routing, we need the information about IP addresses. So in order to learn about the routing, the protocols used are routing information protocol, and similarly for forwarding we have UDP, all this, and for switching we have spanning tree protocols. So in today's class we will talk more about the routing protocols. So you can see forwarding process. I already we understood the definition of forwarding. Forwarding is nothing but moving the packet from one device to the one place to the other place. So to do so, we require forwarding table. This is the forwarding table. You actually it contains 4 columns. So you can see this forwarding table contains the information about mask. So here forwarding process it will use classless addressing. We have seen classless addressing, classful addressing, right? So what for it is used? Can anybody tell me what for classless addressing is used and classful addressing is used? So we will see classless addressing usually in IPv6, right? IPv4 also we can see the classless addressing. So compared to classful addressing, it is more advantageous because we no need to we do not have any classes particularly like class A, class B, like that. It is not there. So usually we have BYN. This BYN represents the number of bits representing the IP address. Sorry, not IP address, it is a network ID. How many number of bits are going to represent the network ID that is given by the notation by n. Right? This information is present in the forwarding table. After that network address we will have, after that we will have next hop address. That means after forwarding the packet, it will reach the next destination. What is the destination of that address? That will be put in the next column, and after that the net interface. So this is very important. So we can see different types of routing protocols. So usually there are two types of routing protocols. So intra-domain routing protocol and inter-domain routing protocol. Here intra-domain means it is within a network. We will see these type of protocols within a network. Like within our campus, like if within a particular network, we are going to talk about two types of protocols, that is distance vector protocol and link state protocol. And other one is inter-domain. So number of intra-domain protocols, if you connect, it will become an inter-domain kind of routing protocol. So this will use a protocol called path vector protocol. These are very important. So that will come under the routing protocols. The first two will be the intra-domain protocols. The last one, that is path vector, is the inter-domain. So we'll see the abbreviations of RIP, OSPF and BGP in the next slide. So you can see the routing information protocol. We can see RIP. It stands for routing information protocol. It is based on the distance vector algorithm. Very important. So this is based on the distance vector algorithm. This we are going to study in detail in today's class. After that, open shortest path first. That is OSPF. It is based on the link state algorithm. So these also we are going to talk about today. And the last one, it is the border gateway protocol. It is BGP. It is based on the path vector algorithm. So among this, the important one I can tell is the distance vector algorithm. So we can see the graphical representation of the internet. We will have the router devices, some LAN devices. So we can see. So you can see the picture here. So these are these are the routers. So these are the LANs. Indication of LANs. These are the WANs, and so we can see these are the nodes. In graphical the same kind of internet kind of picture can be represented in graphical mode. In graphical picture, every router is replaced with a node. So this is the node indicated here, and every LAN connection is replaced by a graphical picture that is called edge. Okay. So you can see the LANs we are using, it is of different performance, it may be different length, different capacity. Okay, so here you can see this edge. So in the figure, this edge is nothing but the LAN. You can understand in the graphical representation, this is the simplest form of representing the network. Here each node represents the router and each edge represents the LAN. Okay, here you can have a doubt that what are these values represent. These values are represent the cost. We can that are metrics, we can say. Here we are using this two to represent the link cost. Okay, So that means if you talk about delay, so we can understand that this particular link is providing the delay of amount 2, and this particular amount of path provides a delay of amount 3. Okay, so to pass the information from A to B, so what is the delay? Can anybody tell me what is the delay? Can anybody tell me what is the delay? So it is 2. Similarly, to pass the information from A to D, the amount of delay is 3. Okay. So this is a simple representation of an internet in terms of the weighted graph, we can say. So in order to understand all the protocols, like whatever I have explained, so that is the distance vector algorithm, link state algorithm, and path vector algorithm, we need to know what is minimum distance. So that is we can see least cost routing. This is very important. The concept of least cost routing. ఎక్కడ స్టాప్ అయిందో తెలియడం లేదు నాకు. So I will again start from beginning. So you can see. So today's topic is about the forwarding and unicasting protocols. Already last class లో మనము ARP protocol, RARP protocol ఇవన్నీ చూసాం కదా. So ARP protocol, RARP, these are mainly concerned about mapping of IP address to physical address and physical address to IP address. Yes or no? Right? So today we will see the next topic, that is last topic of the 4th unit, that is a forwarding and unicasting protocols. So forwarding and definition we will see, and after that what are routing protocols we will see. So you can see the next slide. So that is this one. So I'll make it full screen. So forwarding. What is a forwarding usually? The definition, forwarding means మనకు జనరల్ గా ఫార్వర్డింగ్ అంటే ఏంటి, ఒక ఇన్ఫర్మేషన్ ఇచ్చినప్పుడు దాన్ని ఒక ప్లేస్ నుంచి ఇంకొక ప్లేస్ కి షిఫ్ట్ చేయడం. అదర్వైజ్ ఫ్రమ్ వన్ డివైస్ టు అదర్ డివైస్, ఫ్రమ్ వన్ లొకేషన్ టు అదర్ లొకేషన్. సో దట్ ఈస్ కాల్డ్ ది general definition of forwarding, right? So whenever in the computer networks, whenever a packet arrives in the network layer, so the forwarding table will be there. That table will make sure that packet will move from one interface to the other interface. So this all will happen with the help of routing techniques. Okay, so routing means this, it is a process of movement of the data from one device to the other device. So how the data will move? It will be moving with the help of a table called routing table. Okay, so here routing table will contain the information of MAC address, IP address, and also it will contain along with IP address, MAC address, along with that the extra information also it will contain. That is a particular path if you are telling, so how much delay it will take, how much distance it is, all that information will be there in the routing table. So in order to do that movement, in order to move the packet from one place to the other place, we have to follow certain rules called routing protocols. So these protocols are used to continuously update these routing tables. Why we have to update means, so initially the routing table will be present with minimum amount of information initially. So then that means every hop, we call it as every hop. So after every hop, the routing table will keep updated. Whenever it keeps updated, so the routing table will be keep on adding some new information to it, so that it will have the whole information at the end. So here, so optimizing is very important, because whenever you are transmitting the packet or forwarding the packet from one device to the other device, so ఒక ప్యాకెట్ ని ఫార్వర్డ్ చేయాలంటే, సో సింపుల్ గా దేర్ మే బి ఇన్ జనరల్ దేర్ మే బి మల్టిపుల్ పాత్స్ ఉంటాయి, బట్ we cannot pass the packet through all the paths. We have to choose the one path among the multiple paths that gives the optimized performance. Optimized performance here I mean to say, which takes less delay and less distance. The packet should be carried with less amount of delay, and it should follow at least shortest distance, right? So you can have LAN network with some distance, very high distance, very less distance. So different types of parameters will be there. Among that, we have to choose the shortest distance path to forward the packet, so that all thing will be updated and it will be maintained in the routing tables. So these routing tables will continuously keep updating using protocols called routing protocols. Today we'll see what are that routing protocols available in these computer networks. So these are the differences between the routing, forwarding and switching. సో అగైన్ ఇప్పుడు మళ్ళీ ఏమన్నా మీకు network my class is found to be disconnected, please call me immediately. Okay, so are you getting? Okay, so you can see, so we understood what is forwarding and we'll see what is forwarding process. Usually in forwarding process, so we have to use some kind of addressing. So here classless addressing is used. You can observe here. So in forwarding, the routers, whatever we have, it will maintain some routing table. In that routing table, it will contain information about the IP address, MAC address, all that. So for all that addresses, we use classless addressing. So in classless, how do you specify that classless addressing? Can anybody tell me? How do you specify that classless addressing? So you can see this representation by n is there now. That is used to specify this is a classless addressing. If by n is not there, then it may be classful addressing, right? So usually this forwarding process, it will also maintain a forwarding table. The table contains 4 columns. You can observe here. First column lo mask anedi untadi. Next column network address. Next to hop address, interface. So now tell me what is that by n represents? So this by n represents number of bits used to represent the network ID. Yes or no? Yes or no? Okay. So you see, now we are coming into the actual topic now. So today's class we are mainly concerned about routing protocols. What are the rules? What are the protocols we are following to update the routing table? I said we will maintain the routing table. I said that initially the routing table will be filled with minimum information. So after every hop or after a certain amount of time, the table will keep updated so that it will be filled with a lot of information, right? So for that, so we have two types. What is first one is intra-domain protocol, and other one is inter-domain protocol. So in intra-domain, so intra-domain means within the network. We can see whenever the information is transmitted within the network, so we will follow usually follow two types of protocols. That is distance vector protocol, very important. This is the distance vector protocol and the link state protocol. And the last one, that is inter-domain. That means whenever we talk about communication between two intra-domain networks, so then it comes path vector protocol, right? We'll see abbreviations of what is that RIP. RIP is nothing but routing information protocol. So this protocol is mainly based on distance vector algorithm. So what is the algorithm we follow for RIP? It is a distance vector algorithm. What is the algorithm for we use for OSFP, OSPF? It is a link state algorithm. And last one, that is a border gateway protocol. So this one is based on this routing protocol, which is based on algorithm called path vector algorithm. So these three algorithms we are going to talk about today. So you can see this picture. So to make you understand what are the elements used in the internet, so you can see router will be there. So LAN will be there. So this is the actual internet representation. So which contains routers, LANs, and this is some WAN connection. Here the dotted line represents WAN connection, and the same thing is put in a graphical representation. So here in place of router we have represented some node. So in our networks we have studied now nodes edges like that. So here each router is replaced with a node and each LAN is replaced with the edges. So we can see on the LAN we have defined some value numeric value. This numeric value will represent cost of the path. Okay, so what is the cost? Cost here represents the cost in terms of delay. We can assume if you talk about delay, so this particular path is going to provide the amount of delay is 2. Here the amount of delay is 5. Here the amount of delay is 3. Whenever the information, the communication between these two particular routers, what is the delay means here it is 3. Whenever the communication is between these two routers, that is exchange of information between these two routers, the amount of delay is 1. So that is the meaning of cost here. So we can understand this numeric value as a cost or otherwise as a delay. So anything that is called as a metric, right? So all the algorithms, whatever I explained till now, that is a distance vector algorithm, link state algorithm, path, so distance vector algorithm, link state algorithm, and path vector algorithm. So all these three, or not all these three, the first two are based on least cost algorithm. Okay, here in the first two algorithms, we will find out, try to figure out what is the least cost present. Okay, in the last one, we find out the less number of nodes present, less number of nodes. We will follow. So, Esma, tell me. Okay. So what I will do means, anyway I am recording this video. Okay na? Hello? Can you hear? ఆల్రెడీ ఇప్పుడు క్లాస్ స్టార్ట్ చేసేసాను కాబట్టి ఏం చేస్తానంటే రికార్డ్ చేసి ఇచ్చేస్తాను. ఎవరైతే అటెండ్ అవ్వలేకున్నారో వాళ్ళు చూసుకోండి. ఓకేనా? నో ప్రాబ్లం కదా. ఇప్పుడు ఎవరైతే అటెండ్ అయినారో వాళ్ళు అవ్వండి. అవ్వని వాళ్ళకి నేను రికార్డెడ్ వీడియో పెడతానమ్మా. అటెండెన్స్ ఐ విల్ గివ్. ఓకే. ఓకే. ఓకే మా. ఫస్ట్ దాంట్లో ఏంటంటే, ఈ ఫస్ట్ టూ దాంట్లో less cost. We will find less cost. Okay, we will see the cost of each path. So cumulative cost we will find. So which one is going to give the less cost? That cost we will prefer. Then that is called the optimized path. So in the last one we will see. So whenever you want to transmit the information, if suppose there are three nodes, okay, three nodes are there. The connection is like this. So for example, this is node A, this is node B, this is node C. When you want to pass the information from, so this cost is 2, this cost is 1, this cost is, let me write like this, this is 1. So I want to pass the information from node A to node C. So which path do you prefer? So I am just asking. So it should have minimum number of nodes. Okay, here so last algorithm, I am talking about last algorithm. So if you go with this path, so from node A to node C, how many nodes it is covering? 2 nodes. Okay. So when you go by this path, how many nodes it is covering? How many nodes? 3 nodes, right? So you can see A, B, C. So path vector algorithm will always try to figure out the path which is giving less number of nodes. ఓకే, లెస్ నెంబర్ ఆఫ్ నోట్స్ అనమాట. ఈ పాత్రలో వెళ్ళామంటే 3 నోట్స్ కవర్ అవుతాయి, ఈ పాత్రలో వెళ్ళామంటే 2 నోట్సే కవర్ అవుతాయి. సో ఎనీవే మై ఇంటెన్షన్ ఈస్ దిస్ ఈస్ ద సోర్స్ ఐ am considering and this is the destination I am considering. Therefore what will happen? So the information will be carried from node A to node C with this path, okay, by using path vector algorithm. So path vector algorithm will always focus on transmitting the or forwarding the packet from one source to other destination with less number of nodes. Okay, whereas the first two you can observe. So here also, so if you want to transmit the information from packet, forward the packet from node A to C. So what is the concept in first two means it will always check for the path cost. So what is the cost of this path? What is the cost of this path? 1, right? So what is the cost of this path? 1. Therefore A నుంచి C కి ఈ path లో వెళ్ళాలంటే total cost ఎంత అవుతుంది? 2 అవుతుంది. Similarly A to C ఈ path లో వెళ్ళాలంటే total cost ఎంత అవుతుంది? 3 అవుతుంది. Therefore 2 is least cost or 3 is least cost? Tell me. Yes, 2 is least cost. That is why the first two algorithms, it will mainly focus on which path is going to consider the less cost, that is the least cost, that it will take it as a optimized path. Okay. Now when you consider first two algorithms, obviously the path chosen will be this path. Okay, not this one. Okay, understood now? So path vector algorithm means it will always focus on less number of nodes. తక్కువ nodes కవర్ అయ్యేటట్టు పాస్ చేస్తుంది. whereas ఫస్ట్ టూ ఆల్గరిథమ్స్ ఎలా ఉంటుందంటే ఏ path లో వెళ్తే తక్కువ కాస్ట్ పడుతుందో ఆ path ని సెలెక్ట్ చేసుకుంటుంది. ఓకే, సో దట్ ఈస్ ద కాన్సెప్ట్ ఆఫ్ డిస్టెన్స్ వెక్టర్ ఆల్గరిథమ్ అండ్ లీస్ట్ స్టేట్ ఆల్గరిథమ్. సారీ, లింక్ స్టేట్ ఆల్గరిథమ్. Link state algorithm. Last one is path vector algorithm. To understand all these algorithms, you should understand what is least cost routing meaning. Okay, to understand that we have one figure here. So you can see one figure here. Blue A is given in the blue region. So here least cost tree. So this is very important to understand all the algorithms. So when you want to transmit the information within the same node, అక్కడి నుంచి అక్కడికే ఇన్ఫర్మేషన్ పాస్ చేయాలంటే what is the cost of that path? What will be the cost? Obviously it will be 0. Yes, so suppose I want to transmit the information from A to B. A to B కి సెండ్ చేయాలంటే the cost is 2. Similarly from A to D transmit చేయాలంటే the cost is 3. Okay, but if you want to transmit the information from A to E directly, it is not possible, right? Because for A you can understand D is the neighbor node and B is also neighbor node, immediate neighbor nodes antam anamata. So these are called immediate neighbor nodes, whereas E is not immediate neighbor node for A. Is it immediate neighbor node E? No, because it is not directly connected to the node A. It is connected to node A through B, via B, right? So you understood what are immediate neighbor nodes and what are not immediate neighbor nodes, right? So similarly, if you consider B is the root tree, okay? So if you want to transmit the information within that node, the cost of that will be 0. If you want to transmit the information from B to A, the cost of that particular path is 2. So this is how you can understand the least cost path for B to A. Okay. Similarly for C, if you want to talk about, so if you want to transmit the information within that from C to C only, then 0. Okay, from C to G, what is the cost given? What is the cost given here? 3. Yes. So similarly, you can understand all the figures. It is very easy. So for each figure, they have taken one root tree. This is called root tree. So if you are on root tree and your destination is also root tree, the cost will be 0. Okay. You can see the figure, the legend, the label of the figure. Here, whatever the blue circle is there, that is called root of the tree. And the plain circle, you can see, that are called neighbor nodes or intermediate or end nodes. And what are that numeric values are there on the node, they represent cost. So next we will see the very important topic, the distance vector algorithm. Okay, so to understand this distance vector algorithm, so you understood what are immediate neighbors? Yes or no? What are immediate neighbors? And so there will be exchanging between immediate neighbors. Okay, so always the immediate neighbors will exchange the routing tables. What they will exchange means routing table ఏమైతే ఇన్ఫర్మేషన్ ఉన్నాయో సో అవి ఎక్స్చేంజ్ చేసుకుంటాయి అనమాట, సో దట్ దే విల్ హెల్ప్ ఈచ్ అదర్. సో అందులో ఉన్న ఇన్ఫర్మేషన్ ఇది ఇట్ విల్ బి షేరింగ్, ఇట్ విల్ బి యూజింగ్, అండ్ వాట్ ఎవర్ ది neighbor, immediate neighbors are there, so both will be sharing the routing tables, so they will become much intelligent. So you can see very important, the algorithm used for distance vector algorithm. So the equation used for distance algorithm, it is a Bellman-Ford equation, very important. So Bellman-Ford equation. So this equation, the mathematical form, it is represented like this. So it is the minimum distance. If you have two paths, okay, you can understand. So to reach some destination, you can have multiple paths. Among the multiple paths, which path do you follow means, so which one will give less delay? that is least cost. So that one we will prefer as the optimized path. So in the distance vector algorithm. So very important, the equation of the distance vector algorithm, it is called Bellman-Ford equation. So it is based on finding the least cost. Least cost is nothing but the shortest distance here. So we can have one example to understand the distance vector algorithm. So we can see which one is the root tree here in this figure. Which one is the root tree? So A is the root tree. Okay. So the source is A. If the source is A and distance is also A, so we will write the cost of each link. Okay. Here I am considering the root tree, that is A. So how many nodes I have? Count. How many nodes? 1, 2, 3, 4, 5, 6, 7. So 7, total 7 nodes. So that is 2, 3, 4, 5, 6, 7. 7 nodes are there. So you make a separate row for each node. Okay. So with respect to each node, what will be the cost of that particular path? You can understand the distance vector algorithm. Okay. So this is the source you can consider, and this is the destination. This one is a destination you can consider. So if source is A and destination is also A, what is the cost of that path? Cost of that link? Yes, 0. So 0. Similarly, if the source is A and destination is B, what is the cost of that? 2. So in that way, we can fill this table with respect to the source A and different destinations in the figure. Okay. So you see from A to G. From A to G, if you want to reach, if the source is A and destination is G, there may be multiple paths. What are the multiple paths? In this figure, there is only one path you can find out. So that is like this. Okay. What is the total cost of this path or link? 2 plus 6 plus so not 25. So here you don't misunderstand. So ఇదంతా యాడ్ చేసిన తర్వాత వచ్చిన వాల్యూవే 9. ఓకేనా? సో ఇక్కడి నుంచి ఇక్కడికి ఫార్వర్డ్ అయిన ప్యాకెట్కి టోటల్ కాస్ట్ ఇది. ఇక్కడి నుంచి ఇక్కడికి ఫార్వర్డ్ అయిన ప్యాకెట్కి కాస్ట్ ఇది. ఓకేనా? దీని లిటిల్ బిట్ లేటర్ యూ విల్ అండర్స్టాండ్ దిస్ ఆల్ థింగ్స్. ఓకే. ఇక్కడి నుంచి ఇక్కడికి ట్రావెల్ అయిన ప్యాకెట్ కాస్ట్ ఎంత? 8. దెర్ఫోర్ ఇక్కడి నుంచి ఇక్కడికి ట్రావెల్ అయిన ప్యాకెట్ కాస్ట్ ఎంత టోటల్? 9. Okay, so the source is A and destination is G. According to this figure, the total cost of that path will be 9. Okay, so this is the distance vector algorithm. You understand how the representation is here. Next figure I will show you. So ఇక్కడ చూడండి, మీకు పాత్ అనేది కాస్ట్ అనేది నోడ్ దగ్గర ఇండికేట్ చేయలేదు. ఎక్కడ ఇండికేట్ చేశారు? ఎడ్జెస్ దగ్గర ఇండికేట్ చేశారు కదా. సో హియర్ ద వాల్యూ విల్ గెట్ యాడ్ అప్. ఇక్కడ యాడ్ అవుతుంది. ఓకేనా? సో ఇంతకుముందు నేను యాడ్ చేయలేదు కదా, ఈ ఫిగర్లో నేను యాడ్ చేయలేదు. డైరెక్ట్గా ఇక్కడి నుంచి ఇక్కడికి వస్తే ఆ టోటల్ కాస్ట్ ఆల్రెడీ 9 ఇచ్చారు కాబట్టి 9 రాసుకున్నాం. యూ సీ ద రిప్రజెంటేషన్, ద కాస్ట్ ఈజ్ రిప్రజెంటెడ్ above the node or near the node. Then you no need to add the every node cost. But here you see the representation, how the cost is represented. It is represented near the edge. ఓకే, ఎడ్జెస్ దగ్గర రిప్రజెంట్ చేశారు కదా. సో హియర్ ద కాస్ట్ విల్ గెట్ యాడెడ్ అప్. సో ఫర్ ఎగ్జాంపుల్, సపోజ్ నేను ఏ నుంచి ఈకి వెళ్ళాలి. ఏ నుంచి ఈకి వెళ్ళాలి. ఎన్ని పాత్స్ ఉన్నాయి? ఇట్లా వెళ్ళొచ్చు, ఇట్లా వెళ్ళొచ్చు. ఇట్లా వెళ్ళాను అనుకోండి, 4 + 2 ఎంత అవుతుందిమా? 6 అవుతుంది. ఇట్లా వెళ్ళాను అనుకోండి, ఎంత అవుతుంది? 8 అవుతుంది. ఈ రెండుట్లో ఏది లీస్ట్ కాస్ట్? 6 least cost. కాబట్టి which one is the optimized path for this A to E? Yes, 6 is the least cost. ఇక్కడ యాడ్ చేశాను చూసారా? ఎందుకు యాడ్ చేశానంటే the numeric values represented here that is near the edges. Okay, బట్ ఇక్కడ నేను యాడ్ చేయలేదు. సో it is already added and given. Understood now? Don't get confused. Okay. So in this figure, we will find out the distance vector algorithm for all the nodes. So you see, Here, if I consider the node A is the root tree, node A is the root tree. So how many nodes are there here? So you can write so many nodes. You can see G unnai kabatti up to G you can take. So if you consider A to B, A to A, what is the cost of that? 0. Yes or no? From A to B, A to B ki 2. Okay. So you understand. Next column you can understand very carefully. The A to C, A nunchi C ki. It is immediate node? You can observe. Can you observe? C is a immediate node or not immediate node? Tell me. Yes. So yeah, okay. So whenever the immediate node is not there at that time, we will write as it as infinity. If it is immediate node, then only you can consider the particular path value, cost value. Okay. Once it is not immediate node, you just put it empty here. Sorry, infinity here. Okay. Similarly, in the figure, so from A to E, you can see A nunchi E ki. So is it immediate node for A? No. So that is why E is infinity. ఎక్కడైతే మనకి ఇమీడియట్ నోడ్స్ కనిపించవో అక్కడల్లా మనం ఇన్ఫినిటీ పెట్టుకోవాలి. ఓకేనా? సిమిలర్లీ ఇఫ్ యూ టాక్ విత్ రెస్పెక్ట్ టు బి, ఇప్పుడు బిని రూట్ నోడ్ లాగా తీసుకోండి. ఓకే, ఇఫ్ యూ టాక్ అబౌట్ బి, ఓకే, ఫ్రమ్ ఏ బి టు ఏ, what is the cost 2? From B to B, it is 0. From B to C, it is immediate node. That is why you have taken 5. But from B to D, D is somewhere here. It is not immediate node. Okay, that is why it is infinity. Is it clear? So in that way, the distance vector algorithm, it will all happens in the first hop. Okay, first cycle lo idi jarugutadi, ila jarugutadi. Okay na? So similarly for C also you can have the distance vector algorithm in the first hop. You will have infinity values. So you understand what are the meaning of infinity values, that are not the immediate neighbors of that particular root node. Okay. Similarly for D also. Similarly for E also. Similarly for F, and finally for G also. You can have infinity values as well as 0 as well as some path values. Okay. So this will all happen in the first cycle. So like this, every time the uh, distance vector algorithm will keep updating these values. So in the first hop it is infinity, no? These infinity values will be replaced with some new values, that is updated values in the next hop. How it will be replaced? You can see for A, C is not immediate neighbor, but for B, you can see for B in the figure, you see, you can easily understand. For B, C is immediate neighbor or not immediate neighbor? Immediate neighbor. Okay, like this. So in the next hop, even though the for A, C is not immediate neighbor, but for B, C is immediate neighbor, and A and B are immediate neighbors. That is why, so you can see the infinity value will be replaced with a new value, that we call it as updating the table. So you can see after each node, you can observe here, after each node has created its vector, it sends a copy of all the vectors to all its intermediate immediate neighbors. After a node receives a distance vector from a neighbor, it updates its distance vector using Bellman-Ford equation. Okay, so what I mean to say is, if I want to reach C, so how do I reach? Can I reach directly? I cannot reach directly. I have to reach with the immediate neighbor. Okay. First it will go to B. After that it will go to, from B to it will go to 5. So this is one possibility. Otherwise you can see different paths also are available. Among that, which one is providing the least cost, that path I will follow. Okay. So this information will be added in the table in the after every hop. Okay. You can see very important. This one is very important. So in this figure, so you have the distance vector table for B. So already whatever we have seen in this B, okay, 2, 0, 5, infinity, 4, infinities. So that same thing. So here also we have, so 2, 0, 5, infinity, 4, 2 infinities, right? So this is the old B. So the new B, you can see after every hop, the B, every vector table will be updated. In what way it will be updated means, so you can see, so in the old B, what I said, B key, D key immediate neighbors kaadu. B and D are not immediate neighbors. That is why it is infinity. Okay. But if you read the B with respect to A, so but for A, what is the D? D will become immediate neighbor. So this D is immediate neighbor for A, and what is the cost of that? 3. Okay, so now we can see the figure. So this is 3. Okay, so in the figure we can see. So if I want to move from B to A, so what is the total cost? It is total cost is 2 plus 3 is 5. Okay, so otherwise if you go by this, so you can go by this also, but cost will become 9. So always we prefer least cost. That is why we use 2 plus 3 is 5 only. That path only we will prefer. That is BAD. So that even you can observe here. So before it was infinity. So during the first half, after it gets updated with new value, that infinity is replaced with 5 because so to reach from B to A, there are two paths available. One is from BAD, another one is BA, some other node is there. Among that, one is 9, other one is 5. So among 5 and 9, 5 is the least path. So that will be replaced with the infinity. Okay, in this way, every time the distance vector table will be keep updating. In the updation process, the infinity values will be replaced with some minimum cost path. So understood how that infinity is replaced with 5? So now this will become the new B table, new distance vector of the B. Okay. Similarly, if you talk about B with respect to E, okay, so you see from B to E, so you can understand that with the figure only, you can see B to E. So what is the cost? 4, right? 4. Initially it is 4. From E to A, what is the cost? It is infinity, because in the first hop it is infinity, but in the next hop, if you want to reach the A, from E to A, so which path do you prefer, this path or this path? There are two paths available, 4, 5, 6. So if you go by this, it will be 6. If you go by this will be 8. For which which path do you prefer? Obviously the least cost path only. So that is why we can see in the new table. So it is so you can, if you talk about with respect to F, so it is 2. So it is not immediate neighbor. That immediate neighbor will be replaced with 6. The value 6. So can you are you understanding this one? So in this way, every time the old B table will be updated with new B table. Like this, every node will be updated with new distance vector. Here we are talking only about node B. The same thing will happen for node A, node C, node D. All the nodes will get updated every time. So in the updation, what is happening? The minimum cost path will be found out. So this is called distance vector algorithm. So there is an program written for this distance vector algorithm. So it is having the y that is representing the number of nodes, how many nodes we are having. So suppose from 3 nodes we are having, so we have to find the immediate neighbor. If it is the immediate neighbor, then we will have some value for that path value. If it is not the immediate neighbor, then that particular path value will become infinity. Okay, and we will, if it is infinity, then we have to path again, we have to update the table with some new value. That new value is found out by taking the minimum value between the two values. We will have multiple values. Among the multiple values, which one is giving the minimum value, that value we consider as the optimized path. So this is the next algorithm. So this is a linked state routing. So this is the next algorithm, very important, linked state algorithm. So here also the concept is least cost tree only. So in the previous one also we are focusing on the least cost. Here also we are focusing on the least cost, and we are updating the forwarding tables. Here the main concept of this link state routing here is flooding. So we will forward the information about the router to all the nodes present in the network, to all the nodes present in the network. So how it will happen, we will see. Flooding is very important here. So here is some figure. So this figure also containing some number of nodes with some path, cost of the path. So it is given. So here there is a table. So single table is provided. This table, whenever infinity is present, so you can understand that it is mostly the first hop process. Okay. So first of, if you talk about A to A, same story repeats. A to A 0, A to B 2. So you can see the same thing. So B to A, the same story. So like that we can fill the link state database. This is the link state database. This will be present initially, but every time it keeps updating. Okay, so as we discussed in the distance vector algorithm, so every infinity value will be replaced with the minimum path value. Okay, so we can see the link state algorithm. It is operation. The main concept of this is a flooding. Flooding means, you can understand, this A, the node A will forward the packet, or it will forward the routing table of its own to its nearest neighbors or immediate neighbors. What are the immediate neighbors of A? Can you tell me? B and D. B కి D కి మాత్రమే ఫస్ట్ పంపించేస్తుంది అనమాట. సో ఈ బి ఎందుకంటే ఇమీడియట్ నేబర్స్ కాబట్టి. ఈ బి ఏం చేస్తుంది? సో దీన్ని రౌటింగ్ టేబుల్ని ఈకి పంపిస్తుంది, ఏకి పంపిస్తుంది, సికి పంపిస్తుంది. ఓకే, ఈ ఏం చేస్తుంది? దీని రౌటింగ్ టేబుల్ డికి పంపిస్తుంది, ఎఫ్కి పంపిస్తుంది, బికి పంపిస్తుంది. ఈ ఈ ప్రాసెస్ని ఏమంటామంటే ఫ్లడ్డింగ్ అంటాం. సో యూ కెన్ సి flooding is a very important concept in the link state protocol. Here flooding means each node sends, see you can see each node sends the link state packet. The link state packet means it contains the information about the path, delay, and source, destination. All those things are present in the link state packet. So to all its immediate neighbors. So immediate neighbors ki పంపించేస్తుంది. To collect two pieces of information from each neighborhood. What is that packet containing means the identity of the node. What is the identity of that node, and what is the cost link of that node. Okay, to reach from A to B, what is the cost and what is the identity of that node. That all information is present in that flooding packet. Okay, flooding happens. So this will, flooding means you understood. So the node, if you consider, it will forward the packet to its nearest neighbors, and this B will forward the packet to its nearest neighbors. What information does that flooded packet contains means it contains the information about identity of the node and the cost of the node. Okay. So now what I want to tell you means, you can see, so by flooding the packet, what is the understanding means, you see, ఈ ఏం చేస్తుంది, ఈకి దానికున్న ఇమీడియట్ నేబర్స్ గురించి. సో ఈకి డి ఉంది, బి ఉంది, ఎఫ్ ఉంది. సో ఇవన్నీ ఉన్నట్టు దాని కాస్ట్ ఎంత, ఏవేవి ఉన్నాయి ఆ ఇన్ఫర్మేషన్ అంతా కూడా నేబర్స్కి సెండ్ చేస్తుంది. అంటే ఈ డీకి సెండ్ చేస్తుంది. సో దట్ ఈ విల్ అండర్స్టాండ్ దట్ డి విల్ అండర్స్టాండ్ దట్ ఈ ఈజ్ హ్యావింగ్ ద నేబర్స్ యాజ్ బి, ఎఫ్ అండ్ డి ఆల్సో. సో డీకి అర్థమవుతుంది అనమాట. అప్పుడు ఏమర్థమవుతుంది, ఈ ఈకి ఎఫ్ కనెక్ట్ అయింది యాజ్ వెల్ యాజ్ బికి కనెక్ట్ అయింది. అంటే డి విల్ అండర్స్టాండ్ దట్ so even though that D is not immediate neighbor of D, it is the immediate neighbor of D. So like that it will figure out. So due to flooding effect, the not immediate node will recognize that what are the immediate nodes of that E. Understood? Okay. So you can see, so if I consider node A, so to the node A, what are the immediate neighbors? Yes, B and D. I said flooding will happen. That flooding will contain information about node information as well as cost information. Similarly, with respect to B, so what are the nearest neighbors? A and C as well as E. సో వాటి గురించి ఉంటుంది, నోడ్ ఐడెంటిటీ గురించి ఉంటుంది, యాజ్ వెల్ యాజ్ పాత్ కాస్ట్ గురించి కూడా ఉంటుంది. సిమిలర్లీ సి కూడా ఆ ఫ్లడింగ్ జరుగుతుంది కదా, ఫ్లడింగ్ ప్యాకెట్ ఏం ఇన్ఫర్మేషన్ ఉంటుంది అంటే ఈ ఇన్ఫర్మేషన్ ఉంటుంది. సిమిలర్లీ డీకి ఏంటి నేబర్స్? ఏ అండ్ ఈ ఇమీడియట్ నేబర్స్. సో ఏ ఉంటుంది, ఈ ఉంటుంది. సో దాని కాస్ట్. సిమిలర్లీ ఈకి అయితే బిడిఈ. సిమిలర్లీ ఫర్ every node, the flooding will happen to the immediate neighbors. That immediate neighbors will contain the information about the node identity as well as cost value. The path, what is that path cost, least cost or whatever we call, that it will contain. So this thing will not happen in the case of distance vector algorithm. అర్థమవుతుందా? దానికి దీనికి డిఫరెన్స్ ఏంటంటే అక్కడ ఇట్లా ఫ్లడింగ్ అనేది జరగదు. ఓకేనా? So flooding will not happen in case of distance vector algorithm, whereas in link state vector algorithm flooding will happen. ఓకే, ఇలా చేయడం వల్ల ఏమవుతుందంటే, సో దీని పక్కన ఏముంది, సో పర్టికులర్ నోడ్ తీసుకున్నప్పుడు దాని పక్కన ఏముంది, నేబర్ ఇమీడియట్ నేబర్స్ ఏంటి, నాట్ ఇమీడియట్ నేబర్స్ ఏంటి అనే ఇన్ఫర్మేషన్ అనేది ఫిల్ అవుతుంది టేబుల్లో. ఓకేనా? సో దట్ కైండ్ ఆఫ్ ఇన్ఫర్మేషన్ యూ విల్ గెట్ ఇన్ ద కేస్ ఆఫ్ లింక్ స్టేట్ ప్రోటోకాల్. Okay, so but what is the disadvantage of this means, so here whatever we are talking about flooding, so flooding it requires more bandwidth, because so this you can see so much of information it has to gather, it has to update, so it requires much bandwidth, more bandwidth compared to the previous one. It requires more bandwidth, so that is the one disadvantage here. So now we can understand what is the difference between the distance vector algorithm. Here each router tells its neighbors what it knows about the whole internet. Okay, in the link state routing algorithm, each router tells the whole internet what it knows about its neighbors. Okay, yes or no? So you can easily understand this too. So here each node will tell to the nearest neighbors, immediate neighbors, about whole internet. This is very important. So in link state algorithm, so this is a link state protocol. So Dijkstra algorithm is followed. Dijkstra algorithm is followed. So this algorithm is, as we understand, it is a kind of algorithm used to find the least cost. Okay. So depending on number of nodes, we will assign y is equal to 1 to n. So if it is a nearest neighbor, we will assign the particular cost. If it is not nearest neighbor, immediate neighbor, we will assign infinity as the cost. Okay. Same thing. So if you have multiple paths, among the multiple paths, which one is giving the minimum path, the minimum cost, that we will consider as an optimized value. This is called Dijkstra algorithm. You can see this figure. So initialization. Okay, initially it will be like this. So you can see 0, that is node A. So here have the some cost, path cost. From node A to node A, what is the cost? It it is 0. From node A to B, what is the cost? 2. From node A to C, 0. Sorry, infinity. Infinity means, is it nearest neighbor, not nearest neighbor? Not nearest neighbor, right? See, initially it will be infinity, but in these infinities will not be infinity only till the number of hops. As the number of hops increases, so these infinities will be replaced with minimum path values, right? Okay, you can see the first iteration. So they have taken some figure. So in the figure they have decided, so they have considered in the first iteration the minimum cost to reach from A to C. What is the total cost? 7. So in the first initialization process, it was infinity, but in the first iteration, what it has become? 7. Okay, in the first iteration, what is the cost? It has become 6. From A to D, what is the cost? 3. Okay, so every iteration, the infinities will be replaced with some numeric values. It is based on the least cost values. So here also same thing you can see. So these two are infinities. So in the next third iteration, the F infinity was there. That F infinity is also replaced with some numeric value. So this numeric value represents least cost. If you want to reach from A to F, what is the total cost of that path? Yes, very good. So that is 8. Okay, so you cannot reach from A to G in the third iteration because it is infinity. If you want to go from A to G, so you can have another iteration. So in the iteration 4, you can have see the path from A to G. What is the cost, minimum cost? It is 10. Okay, so you can have two paths to reach from A to, so A to G. That is this path. Other one is this path. So which one do you prefer? This path or this path? Yes, iteration 5, because it is having the least path, least value, that is 9. So like this, the Dijkstra algorithm will update the table every hop so that it will have a least cost value. Okay, it will have source point and destination point. We will choose the least path value. So last one is the path vector routing. So in the path vector routing, what we will focus, tell me? We will see the number of nodes. We will not count for the cost value. What we will count? Number of nodes. So always we prefer least number of nodes. We will not consider more number of nodes. If it covers more number of nodes, then we say that it is not preferable. If it consumes less number of nodes, then that is called path vector routing. The main agenda of path vector algorithm is we will choose a particular path such a way that it contains less number of nodes. So you can observe here. So in the link state algorithm or distance vector algorithm, we were mainly focusing on the least cost goal. Whereas in the path vector algorithm, we will be focusing more on the less number of nodes. So the here also least cost goal only, but it is mainly on the less number of nodes. So this path vector algorithm, it is based on spanning tree algorithms, path vector routing protocol. It is based on spanning tree algorithm. What is spanning tree means? Spanning tree is one which will not contain any loops. So no loops. One you write like this. Here there no possibility of loop should not be there. That kind of path we have to establish. So usually this is the internet which contains some loops. Okay. So whenever we talk about path vector routing protocol, we should form a path such a way that it should not have any loops. So here we are not writing any edge here. If you write edge here, so it will become a so it will not become a spanning tree algorithm. It will not obey the spanning tree. Spanning tree means so no loop should be formed such a way that we have to find the path. Okay, so now you can see this is the A spanning tree. If you consider A is the root tree, to move from A to E. So otherwise I can, okay, next figure I'll see. So this is the root tree for different spanning trees are written. So such a way that there is no loops. Very important. There is no loops. Okay. So here also you can observe there are no loops here because it must obey the spanning tree. In spanning tree, no loops should be there. So this is spanning tree. So if you make connection here, what will happen? Loop will be created. So that will not be created. If you make any edge here, that is also not correct. So here also if you make connection here, so it is not correct. So this path vector are made at booting time. When it is made means it is made at booting time. So this path vectors you can see, so it will be made like this. So if you consider with respect to A, so from A to A, so the destination, here we do not write the cost path. Okay, path of that cost. You can see we are not focusing on path of the cost. We will just talk about source node and destination node. Only these two we are going to focus. So to move from A to A, what is the source and what is the destination? Source is A and destination is also A. Okay, if we move from A to B, so this is the source. So what will be the destination? B. Okay, so because these two are neighbors, so that will be existing, path vector will be existing here. But when we talk about a to c, because c is not immediate neighbor of a, so no path vector will exist here, no path vector will exist here also, because so this c, d, e are not immediate neighbors of a. Similarly, if you talk about b, what are the immediate neighbors? C, D, A are the immediate neighbors. These are the immediate neighbors. These are the source. These are the destination. Okay. B is the source. A is the destination. B is the source. Destination is also B. Okay. Like that, everything will establish, but only except C, because it is not immediate neighbor. Okay. E is not immediate neighbor of P. That is why this will be not filled in the path vector. Similarly, you can write for C also. For C, what is not immediate neighbor? A is not immediate neighbor. Not immediate neighbor. Okay. Similarly, for A, what are the immediate neighbors? C and D are the immediate neighbors. A and B are not immediate neighbors. These are two are not immediate neighbors. Okay. Like that, path vector table will be filled depending on the source node and destination node. Here, no cost will be, path cost will not be considered. So very important, no path cost. Path cost is considered here. Okay, so only the source node is considered and destination node is considered here. Okay, now let me tell you how this path vector algorithm will optimize the path. Okay, you see, if you want to communicate from A to A to C. So how many paths are existing? So this is one path. Okay. Okay, that is one path. From A to C is, this is one path. And how can I reach? I can also reach like this. This is also one path. Okay, multiple paths will be existing. Here I am writing only two. So among these two, this is covering how many nodes? How many nodes? 1, 2, 3. How many nodes it is covering? 1, 2, 3, 4, 5. 5 nodes. So which is covering less number of nodes? Yes. So this path will be chosen. So whatever we choose the path, it should contain less number of nodes. That is what the path vector algorithm is about. Okay. Here we are not focusing on cost. What we are focusing? We are focusing on number of nodes. So here also, every time the path vector table will get updated. Okay, so like this, so every time the path vector will be updated, you see, So even though the E is not immediate neighbor of A, but E is the immediate neighbor of C, and C is the immediate neighbor of B, ultimately the E will be filled with that particular whatever the empty was there, that will be filled after every updation. Empty places will be filled after updation. So this is called updating the path vector. Okay, so you can see one example here. So you can see the equation. So we can have multiple paths with the number of nodes. So among these, which one is having the less number of nodes, that will be chosen as the best path. Okay, so you can see this is the old value. So from C to A, sorry, C to B. So you can see from C to B, sorry, C to A. You can see C to A, there is no, C to A is not immediate node. So A is not immediate node, but A is the immediate node for A. A is the immediate node. A is the immediate node of B, right? So even though the C is not immediate node of A, but A is the immediate node of B. Yes or no? So due to that reason, so that whatever the empty was there, that will be filled with CBA. So in that way, every time the empty fields in the table will be updated with not immediate nodes also. Okay, intermediate nodes we can call it as intermediate nodes. So that is whenever we want to move from A to C, so with the help of immediate node that is B, we can make that particular field as CBA. Okay, similarly one more example. So we can have the D table. So initially it was empty. Okay, from D to A, it is empty. Okay, but with respect to C, so already it is a new table with respect to C. So you can see for C to A. So C is has become neighbor. Okay, like intermediate neighbor for A with respect to B. So this particular value will be updated in the new C. Okay. This is called path vector algorithm. So here also same thing, but instead of the number of the least cost value, here we are talking about the least number of nodes in this concept. So here there are differences. What are the differences between the distance vector algorithm and the link state algorithm? So both are same, but here the link state will be using flooding concept. Okay, okay. So distance vector will be not using flooding concept. Due to this reason, flooding will be it will be, you can see it is very fast. Flooding ఉండడం వల్ల fast ఉంటుంది. So distance vector it is little bit slow. Okay. So what is the algorithm here? It is following in distance vector algorithm. So we are I said it is a Bradford algorithm, whereas in link state algorithm it is Dijkstra algorithm. So and as well as differences between link state, distance vector and path vector. Okay. So you can see different algorithms. So Dijkstra, Bellman's fold and local policy to rank paths. Okay. So what is the disadvantage in the link state algorithm? That is called flooding is one disadvantage. And what is the disadvantage in distance vector algorithm? Due to the absence of flooding, it is very slow. That is the disadvantage. And what is path vector algorithm? It is also slow because it has to explore the path exploration. Every path it should know how many nodes it is containing in that particular path. So all that matters here. And what are the protocols used in link state algorithm? So that is OSPF, Open State Protocol first, and distance vector algorithm. So that is RIP, and path vector algorithm, that is BGP. So these are the protocols used in the different types of routing vector algorithms. So this is for today's class. So thank you, Ma.